Hey everyone, welcome back and thank you for coming back. My name is Duncan and today I'm going to talk to you about object-oriented programming. So we have covered the first three parts of the University of Helsinki's massive open online course. We've looked at things such as loops, we've looked at arrays and lists, and now we're going to begin our dive into object-oriented programming. So let's have a little look and see what we're going to be up to today. So by the end of this session, we're going to be familiar with concepts of class, object, constructor, object methods, and object variables. We'll understand that a class defines an object's methods and that the values of instance or object variables are object specific. And we'll know how to create a class and objects and know how to use the objects in your programs. So it sounds like a lot, but there are some really good ways that we can remember the difference between objects and instantiation and all these good things that we're going to be looking at. So we'll begin our journey into the world of object-oriented programming. We'll start with focusing on describing concepts and data using objects. From there on, we'll learn how to add functionality or methods to our programs. Object-oriented programming is concerned with isolating concepts of a problem domain into separate entities and using those entities to solve problems. Concepts related to a problem can only be considered once they've been identified. In other words, we can form abstractions from problems that make those problems easier to approach. Once concepts related to a given problem have been identified, we can also begin to build constructs that represent them into programs. These constructs and the individual instances that are formed from them, or the objects, are used in solving the problem. The statement programs are built from small, clear and cooperative objects may not make much sense now, however it will appear more sensible as we progress through the course, perhaps even self-evident. Classes and objects. We've already used some of the classes and objects provided by Java. A class defines the attributes of objects, the information related to them, and their commands or their methods. The values of instance variables define the internal state of an individual object, whereas methods define the functionality it offers. A method is a piece of source code written inside a class that's been named and has the ability to be called. A method is always part of some class and is often used to modify the internal state of an object instantiated from a class. As an example, ArrayList is a class offered by Java, and we've made use of objects instantiated from it in our programs. Below, an ArrayList object named integers is created and some integers are added to it. So here we go, we've got our object being created from the ArrayList class. So this is the object here, that we're going to be used. And then we're using its methods. So in this one we're using the add method and we're adding these numbers to the integer object, or integers object, sorry. And here is another example. So there's a class called system. And then if we look in there, we will have an out method perhaps. In fact, you know what, I'm not sure about system out.println. I know that system is a class, but let's have a look at the .out and .println. So what we can do is open any of our projects. So here you can see we've got our system.out.println, and we can left click on the system and it will take us to the class. So I think we've looked at this before with string, but you can see that all of the different methods that we can access are in here. So if we go back to our main class here, we can click on the scanner class, for example, and then this is the scanner class and all of the methods that we can use. Okay, so you can see here that there are all sorts of different things that we can use. So hasNext, we've used these before. .next as well, we've used these. So you've already been using classes and methods on a dot notation without actually realizing it, which is great because it makes learning it much easier. So an object is always instantiated by calling a method that created an object, which is more commonly known as a constructor. We've already done this, so I'm just going to move that to the left. In fact, move it to the right because I always have my code on the left, don't I? This is the class, this is the object, and what we're saying is that we're creating a new, or we're instantiating the scanner class and creating the, in this case, scanner object. Okay. I'll give you an example later because I think they'll probably cover what I was going to say, but if they don't, I'll go through a few examples. So a constructor is just a posh method. So we recognise this as a method. Constructors can have all of this stuff in them, but they tend to take a few arguments, and they will, like I say, instantiate or create the physical form of the class. So a class lays out a blueprint for any objects that are instantiated from it. Let's draw from an analogy from outside the world of computers. Detached houses are most likely familiar to most, and we can safely assume the existence of drawings somewhere that determine what exactly a detached house is to be like. A class is a blueprint. In other words, it specifies what kinds of objects can be instantiated from it. So we can code a house. Let's just see if they give us an example. They don't. So what I will do is create a new project. And this is just going to be some examples, just to show you, the difference between instantiation, objects, and classes. So I'm just going to call it example. Okay. There we go. So we've got that here. Let's open this up. That's a bit annoying. It hasn't created me any classes, but that's fine. We can add those in. So we've got new class. I'll just call this one main class. And that's just going to have our main inside it. Okay, so it hasn't. So the keyboard shortcut for a new main is public static void main tab. Okay, that's quite cool. And we're going to use our main to instantiate or create our classes. So I'm going to create one for a house. So I'm going to call this house. You can call it house blueprint. In fact, no, let's just call it house. Let's keep it simple. So our house is going to have certain things. So it's going to have walls, ceilings, floors, windows, doors, and we can create all of these as programming variables or data types. So we could say private string house type. So this could be, so we could say that is, for example, it's going to be a detached house. So like in this example. So we just put detached, semi, terrace, etc. Just minimize that. So we've got the type of house. What else can we have? We can have bedrooms. So private int amount of bedrooms. That one's pretty self-explanatory, so I won't put any notes on there. What else can we have? We can have windows, floors. Let's do floors. Private int floors. Just as well, I'm using PR and then pressing tab to get private up so quickly. Let's think, what else? Windows, that's going to be a number. Let's use something that isn't a number. Let's do private string rooms. Realistically, we'd probably do that as an array, but for this example, we won't. So, kitchen, living room, bathrooms, etc. Okay, so this is going to be our basic house. So at the moment, this is just a blueprint of what is going to be. It's not actually created just yet. So before we go creating our house, we need to create a constructor. And remember, a constructor is just a posh method. So what we are going to do is say public house. I'm going to open and close some parentheses and some curly braces. And notice that I've given it a capital H. Normally when we create methods, we use camel case, don't we? So camel case, remember, is the first letter is lower and then every subsequent first letter is capital. So this is an example of camel case. Okay, but for this one, because it's a constructor, we've used a capital H. Okay, so our, just put here start of constructor, and then in brackets posh method. Okay, so what we're going to do is we are going to pass some arguments to this method. So we need to put the parameters in here. So we're going to say string house type int. I'm just going to put num of beds. Num of beds. And then int floors. And finally string room. I'll call this one room names because this will help demonstrate something as well. So all we've got are our, I'll just make this bigger. So we've got our parameters that we're passing. So when we create this object, we're going to need to pass it, give it some arguments, which we'll go through later, but at the moment these are called parameters. And what we're going to do is we're going to update these variables or these values with whatever information we pass it here. Okay? So the first thing we're going to do, and we'll get into this in a bit more in detail, so take this with a bit of a backseat view, and hopefully when we get to this point in the lesson, in this sort of tutorial, you'll think, that's what he meant, or that makes sense now. So like I said, I want to give you a few different examples to hopefully build on this knowledge of objects that you are developing. So we're going to use a keyword called this, and again we'll go through that in a bit. And we're going to say this dot house type is equal, so we're saying that this one here, house type, is equal to this house type. Okay, so that sounds a bit odd, but this will hopefully make more sense as I do the number of bedrooms and the room names one. So this dot amount of bedrooms, so that's this one, is going to be equal to this one, num of beds. Int floors, so this int floors is equal to floors, and then finally this dot rooms is equal to room names. So what I found really confusing when I first started learning about object-oriented programming is that these parameters here were always the same name as these variables here. So you would have this house type equals house type, which we've got here, this amount of bedrooms equals amount of bedrooms, this dot floors equals floors, etc. And I initially found it quite hard to see the similarities and differences between these parameters and these variables. But basically all we're doing is we're passing some variables in, and we're saying that these variables, which are these ones here on the right, are going to be stored in these variables. So if you think about it, this house type, which is this one, is equal to whatever we pass it here. This amount of bedrooms is equal to num of bedrooms, so amount of bedrooms equals num of bedrooms, floors equals floors, and rooms equals rooms. So you can see how these correlate together. And at the moment you may notice these have no values. There are no equals 0 or equals detached or anything like that. And that's one of the sort of beauties of object-oriented programming. So I'm going to drag this over here, and I'm going to create our first object. So if you think about the scanner class that we've been looking at, we said scanner equals new scanner. So again, quite confusing, not especially helpful. But if we replace the word scanner with house, we will end up with something that actually works. So we'll have house equals new house. Okay? So we've got an error which is expected, or I expected it anyway. So the error will say that it's expecting some arguments and it hasn't got them. So let me just see if I can hover that over here. So it says on the second line down of that error that it requires string int string. Now if you look at our constructor on this side, string int string. So hopefully that's sort of jogging your memory with the methods that we looked at earlier in the course. So we know a string has to go between double quotes, so I'm going to say detached. We need two integers. The first integer is going to be number of beds, so I'm going to say 5. The second integer is the amount of floors, so I'm going to say 2. Actually, you know what, I'll have a bungalow, it's going to be a one floor property. And then the last thing are a list of rooms. So if we normally, when we're creating lists, we would think of using a list or an array or something like that, but just for this example I'm just using strings. So let's just quickly list out some rooms. So we'll say kitchen, living room, bathroom. Okay. Oh my days, it's all going horribly wrong. Bathroom, there we go. So we have created an object. So you can see here we've got a house. And just to prove that we have a house, we can do system out print house. This is going to be a bit odd when we print it, when we play the code. So we've got this unusual output down here, and believe it or not, that's actually what I expected to happen. You notice that we haven't got an error, there's nothing red up here, it's absolutely fine. And like I say, this is what I expected. And the reason being is that it displays the object's class name representation followed by this @ symbol and then a hash code. So like I say, this is expected but not ideal. So what we need to do is add in an override to the .string method. So to get that menu up, I use the keyboard shortcut Alt and Insert, and then I'm going to go to string, and we're going to override all of these. So we're going to click generate, and we've got this lovely bit of code auto completion here. There are other bits of code autocomplete. So for example, if I delete this, press Alt Insert, go to constructor, select all, and then generate, it creates our constructor for us too. And there are other things in there that we can create and auto generate as well. If we print this out now, we will get a nicer printout, although it still won't be great because it will follow this sort of format. So we could change this to property, for example. We could change this from house type to home style. We could remove this comma, add in a \n, remember that's an escape character, and it will return the next line, or that line on the next line of code, sorry, on the next line down. So you can see here it's starting to look a bit better. But I won't go through all of it because that's not really the point of this. What I will do though is create another home, another house, or another instantiation of the house class. And this one I'm going to call bungalow. And again, remember you can call the name anything you want. You can call it something useful, something silly, whatever, it doesn't matter, as long as you continue with that reference throughout your code. So this one is going to be a 3-story house, a townhouse. So that can be detached still as well, so detached. It's going to have 3 bedrooms, 3 floors, a kitchen, living room, ensuite, and I think that'll probably be fine. And then we can put the semicolon there. So I'm going to change that to townhouse because it's no longer a bungalow, and correct my mistake here because that needs to be house, not home. There we go. And then we can use our system out. So remember again, the system out shortcut is SOUT followed by the tab on your keyboard, and what we're going to do is print out townhouse like that. Then we're going to hit F6 on the keyboard or press this button here, and that will run our code. And then we'll have 2 printouts, so you can see this is the detached home and this one is the detached 3-story townhouse. So that's one example of using classes to instantiate objects and printing those objects out. Okay, so we'll head back to here. Let's make this a bit bigger, and we can carry on with this example. So hopefully that gave you a bit more of sort of a link to this. So individual objects, detached houses in this case, are all created based on the same blueprints. They're instances of the same class. The states of individual objects, or their attributes, such as wall colour, the building material of the roof, the colour of its foundations, the doors, materials and colour, may all vary. However, the following is an object of a detached house class. So we're on to our first challenge. So let's just move this to the right, go back to my NetBeans, your first account. So let's just see if we've actually got that downloaded. So I need to go to TMC, check for new, oh no, download update exercises, there we go. Oh. And we're on part 4, great, so I'll give those a quick download then. Just while that's doing that, I should probably fix this class and remove all the stuff that I've put in it. Oh, it wasn't in that one, was it? It was an example, that's fine, so I can just delete that. Excellent, so that one's gone. We've got all of our part 4 ones here, so let's have a look at our first account and see what we've got to do. So we've got two classes, which we expect because you need your main class and then the class that you're going to be instantiating. So let's put that here, and remember it's green because there's been an amendment to a Git tracked project. So if we go to Git bash, just to give you all a reminder, let's see. So this is the project folder. So I'm going to copy this and then do cd double quote insert double quote. There we go. And I'm just going to go back up a couple of directories. So doing cd full stop backslash and then 2 enters is how you go back up a directory. And I'm fairly sure that is the one that is being tracked. So if we add that, that will add all of those new bits that we've just downloaded. Git commit, downloaded, finished. So we finished part 3. Downloaded exercises for part 4, and then what we'll do is git push u origin master. There we go. And then if we go to our GitHub, we should see that that's been updated. So / skeleton. There we go. So updated 3 minutes ago. Cool. Right. So let's just minimize that and that. Do not touch the code in the account.java, write your program here. That's fine. So let's just put that here so we can see its methods and things. So this is the constructor, you can tell because it's got a capital A. So that's going to be whenever we create account name equals new account, it will be expecting a name for the owner and a balance. So let's have a look and see what we need to do for this challenge. The exercise template comes with ready-made class named account. The account object represents a bank account that has a balance, one that has some amount of money in it. The accounts are as follows. Write a program that creates an account with a balance of 100, deposits 20 in it, and finally prints the balance. Perform all the operations in that exact order. Okay. So, I'm going to delete that, and I'm going to say account Duncan equals new account. And then if I open and close our parentheses and put the semicolon on the end, we get this error. Remember, if we hover over this error, it will tell us what we need. So it says it needs a string and a double, and we can see here that when we look at the constructor, it's expecting a string and a double. So in here, let's just put Duncan. Did he say an initial balance of 100? With a balance of 100, deposits 20, and then finally prints the balance. Okay, so if we have a look here, we've got some methods already created. I do wonder if saldo is this must be the total one. So that's going to be the one that we call. So we're going to need to deposit 20, so we're going to use this method that they've very kindly written for us called deposit. So we're going to do Duncan dot. It's a bit slow. It's not normally this slow. It should come up pretty much instantly. There we go, deposit. So let's just do that again. So Duncan dot deposit. There we go. And did you notice that it had other methods as well? So you can see. Let's see, what have we got? So we should actually have withdrawal. So you see here we've got withdrawal, and then saldo, and then there's these other ones that we can use as well. But we want to use deposit in this instance, so we're going to do deposit, open and close our parentheses and put a semicolon on. We've got an error because if we look at the deposit method, it's expecting us to pass a double. Okay, and the double that we are going to pass is 20 because they ask us to pass 20 here. And then finally we need to print the balance. So I'm guessing that saldo is going to be the balance print. So we've got that. And then what we're going to do is, we're going to do Duncan.saldo. Let's see if that works. Let's see what we get back. We may have to wrap it in a system out, but that's fine. I should have read their example really, shouldn't I? There we go. So it's ran successfully, but we do need the system out. So I'm going to do system.out.println, and then we're going to open a parentheses, and we're going to put a close one here. Let's try this again, see what we get. There we go, so we've got 120. So let's give that a test locally and see what we get. I imagine they're probably going to want us to make use of this string. So let's just try this. There we go, Duncan balance is 120. So let's just give that a test locally. So because I was returning the balance here, it wasn't working. They were expecting us to use the print for the actual object rather than the print function there, which is fine. But we got there in the end. So hopefully that one made sense. Working with object orientation is a bit, well, when I learnt about it, I found it quite unusual to get my head around programming objects with states and behaviours and things like that. But the more you expose yourself to this code, the more it will make sense, and you'll start to get these little bits of information that seem to slot into place and make sense. So this is definitely a part where you persevere. So that is our first challenge done. That is fantastic. And it looks like we've got our second challenge straight away. The account from the previous exercise class is also available in this exercise. Write a program that creates an account named Matthew's account with a balance of 1,000, creates an account named My account with a balance 0. Do you know what? I don't know why I'm reading from this, because you guys know as well as I do I'm never going to remember all of that. So let's, I'm going to move this over here. Let's get some real estate, some screen space. Oh, busted. Steam opened. There we go. Let's close that. Right, so let us close these. Let's go to our projects. The projects window you can actually open using a keyboard shortcut. So if you press Ctrl and 1 on your keyboard, that will open it. 2 opens the files, 3 opens favourites, 4 opens the output, and there's loads of different things, through to 6. I don't think... oh, 7 does one as well. So just mess around with them, but Control 1 I use regularly, so you can have this come up, but also you can get rid of it, and you've got that extra bit of, extra few inches of screen retail estate. So let's close our first bank account here, and let's open this next one. Okay, so we're probably going to have 2 classes inside the... oh, we haven't got 2 classes. Okay. Right, the account from the previous exercise class is also available in this exercise. Is it? Because I can't see it. I wonder if... okay. Well, I would expect to see another class, but if it says it's available, let's just use Control Alt and T to open our previous... it's not that one, is it? Personal details, it wasn't that one. Name of the oldest, age of the oldest. Oh, I wonder where it's gone. Okay, well I think I can remember it. I think it was account, then account name, wasn't it? So if we say account, so this one was going to be Matthew's account equals new account, and then we need to pass the string Matthew's account like that, and it needs an opening balance of 1,000. So it's going to ask us for an import, maybe. It says it can't find the class, so create class That's weird. I must have missed something because they've specifically said it should be available. So let's use Control 1 to open our things here. I'm in the wrong class. I'm in the wrong package. That's why. So let's try this again. Let's just quickly dock that. Close. It says dog attributes. I should really have seen that, shouldn't I? Let's discard that. So there we go. We've got our two classes. So we've got our account and our first account. So let's get rid of that here. Actually, do you know what? We don't need to move that. But it's going to move it anyway. Excellent. Right, let's put that back. There we go. Oh dear. Okay. So, now this time the code will work. So we'll say account, we can call it A1, I hope for now. If not, we'll just have to change it. Equals new account. So it's a new instantiation of the blueprint, which is called account, if that makes sense. So this is called Matthew's account. That's great, we've got that. We need a balance of 1,000, so we'll pass that. And we're all good, we have no errors, that's great. Then we need to create another account called my account with a balance of 0. Doesn't really seem fair that we get the 0 balance, okay. A2 equals new account, capital M, my account, and balance 0. Cool. We need to withdraw 100 from Matthew's account and deposit 100 into my account. That sounds perfectly feasible and fine. So let's withdraw. So what is the method for withdraw? Let's have a look. So we need this account one, don't we? Actually, if we hold down the control key on the keyboard and left click the account class here, the object, if we click it, it would have opened it. I didn't need to go to the files there. So the method is called withdrawal, and we need the deposit one as well. So what we're going to do is A1, withdrawal, let's see, have I spelled that wrong? Variable A1 type account, let's see. Expecting a double. Oh, I've spelled it wrong. There we go. And in A2, because that's this one, we need to deposit 100. So let's do that. There we go, so that looks fine. And then we need to print both of the accounts. So we can do an S out, and then A1, and then we can do an S out for A2. Cool. So just to clarify, this is Matthew's account. So if you see here, we click A1, it shows us all of the A1s that we've got in our code. If we click on this A2, it shows us all of the A2s that we've created and use them. So let's give this a run locally and see what we get back. There you go, we passed. So let's get that one submitted. Let's just resize this as well while waiting for that. There we go. So that's all done and dusted. Excellent. So remember, you can update your GitHub now. So I'll quickly... I'll update my GitHub when we've finished these exercises. In fact, let's do it now. So let's update our GitHub. So I'm going to press Control 1 again to get the projects open, and I go to Properties because I can't remember where I've saved them. So Sources, and then here's the project folder, so it's in eUsers. So let's just select this. There we go, let's just take that. I'm just going to paste it in here just to make sure that I've got the correct address. That's fine, so we can actually see that we've got our Git hidden folder there. So I'll copy that, open up Git bash, put in our double quotes, press insert on the keyboard, double quotes again, and then you can see that we've changed folders. So we're in the master folder at the moment, and what we're going to do is git add, followed by git commit -m, and we completed, so completed and passed part 04 _ 02 full stop your first bank transfer. There we go, and then the last thing we can do is git push u origin and master. Get that sent off, and there we go, so that's done. So we can click off that and close this down now. And then we can head back here, give that a little refresh. I'll stop the recording here. Hopefully that's been a useful introduction for you into object-oriented programming. As always, thank you very much for watching. I will speak to you next time, and until then, good luck and happy coding.